Question 4 from our Chapter 3 test. I'm asked to complete the square, or not to complete the square, what to add to both sides. And to get that answer, I'm going to complete the square. So the initial equation is 2x squared plus 6x equals negative 13. And then I'm going to divide them all by 2 because the coefficients of x are both divisible by 2. And then to figure out what I'm going to add to both sides, or subtract, I'm going to take b, which is this, and then you take b and you divide it by 2, and then you square it, and that is 9 over 4. So the right answer for this question is C. I can't really read it, so I'm pretty sure it's C, 9 over 4. But 9 over 4 is what you're going to add to both sides of it. Now on to question 5. This is question 5, and it's trying to see if how many solutions are there to this equation, if given that k is greater than 0. And I showed my work by saying I'm going to show my work by saying b squared minus 4ac equals 0 to find k. So it's negative 3 squared minus 4, 2, that's a, k, that's c equals 0, not 9, sorry about that. And then that's 9 minus 8k equals 0. And then I'm going to add minus 9 to both sides, so it's negative 9 equals negative 8k. And then divide both those sides by 8, and that's going to be negative 9 over negative 8. And this equals k equals 1.125. And when k equals 1.125, there will be 0 solutions. I also plugged this into Desmos, so this will be one solution. If it's less than this, there will be 2 solutions. And if it's greater than this, there will be 0 solutions. So there's actually no way to know how many solutions k can be if it's greater than 0, unless you know the precise value of k, and that's what I circled. So I don't know how to change my answer there. Next question I'm going to do is question 8c, and this one uses the rule difference of squares, which is a squared minus b squared equals a minus b times a plus b, and that's difference of squares. And the equation I'm applying difference of squares to is, and the equation that I'm applying difference of squares to is this one, 4 times 2 plus x. It's kind of illegible in the picture, so I'm guessing it's 2. Minus y minus 3 squared. And first, I'm going to take the 2 out, or first I'm going to get the square of this and the square of that. Square of this is 2 plus x minus y minus 3. And then I put brackets around that because I'm going to brackets around this because I'm going to multiply by the same thing again. Except I'm going to make it positive, so it's 2 times 2 plus x plus, instead of minus, y minus 3. And that's fully factored. For number 9, I need to restate the restrictions on x, and I'm going to do that by pulling the 2x minus 4 out of the root. So 2x minus 4 is greater than 0. And then I'm just going to solve this. So plus 4 plus 4 must be greater than 2. And that's their restrictions on number 9. In question 11, I'm going to figure out if the sum of two numbers is 11 and the product of 26.25, what are the two numbers? So I'm just going to write x plus y equals 11. And then x times y equals 26.25. And I'm going to replace y by another x, and I can do that by minusing x from this side, and so it's 11 minus x, or minus x plus 11, so, or negative x plus 11, so I'm going to do that here, and I'm going to substitute y for x. Negative x plus 11 equals 26.25, that's not, that's okay. And next, we're going to multiply this, just solve it basically. So negative x squared plus 11x equals 26.25. And then this I'm going to plug into actually I'm just going to clean it up a little bit. X squared plus 11x minus 26.25. I'm sorry that the equal signs are in order. And then this I'm going to plug into a quadratic formula. So it's x equals negative 11 plus minus 11 squared minus 4 minus 1 minus 26.25, or negative 26.25 over 2 times negative 1. X equals negative 11 plus minus 2 times 121 minus 105 over negative 2. X equals negative 11 plus minus 16 over negative 2. And then that's x equals negative 11 plus minus 4, and you can't simplify that anymore. So I keep it the same, and I'm just going to plug this into my calculator. Negative 11 plus 4 is negative 7 divided by 2, which is x1, which is a negative 7 divided by negative 2, equals 3.5, and x2 is negative 11 minus 4, which is negative 15 divided by 2, which is negative 2, which is 7.5, and those are my two answers. I'm going to check these numbers by plugging them back in. So I'm going to plug in first 3.5. 3.5 plus y equals 11, and minus 3.5 from both sides. Try to keep the equal signs in place. Y equals 7.5, that's this number. And then 3.5 times 7.5 equals 26.25. So these numbers are both right. And now for question 12, it says determine the value of b such that the parabola y equals negative 3x squared plus bx minus 10 crosses the x-axis twice. To do this, I'm going to use b squared minus 4ac and say is greater than 0, so that there is two solutions. So that is b squared minus 4ac is greater than 0, and that would be two solutions. So now I'm just going to plug in the numbers. So b squared, which is the same, minus 4, negative 3, negative 10, yes, is greater than 0. Sorry, that's not line again. Try to fix that. B squared minus 4 times 3, it's 12 times 10, 120, but it's going to stay negative because there's 3 negative signs, so minus 120, 0. And then I'm going to add that to both sides, so b squared is 120. And then, so to figure that out, I'm just going to square root it. And then this equals 10.95. But because it's a square root, we don't know if that was square root of a negative number or positive. So I think you just turn it around, because when you multiply and divide by a negative number, you turn it around as well. So b is 10 pi. And if I pick a number that is less than 11, then when I square it, then I minus it by, minus it by 120 here, it won't be, it'll be less than 0. So it has to be this number or greater. And this is the discriminant, and that discriminant has to be positive, so I can take the square root of it. And that way I get 2 solutions. Okay, this is it. Those are all my corrections. If any of these are wrong, could you please let me know? And thank you.